Welcome back to West Explains Best. Today we're going to be talking about how do we add and subtract radical expressions. This is a Kuta software worksheet. You'll probably get this from one of your teachers in class as a classwork or as a homework. So let's go ahead and get started on how we do this. So what we have here is we have two radical expressions. And you notice they both have radical 7. Now the numbers in front are different. So the way I like to compare this is if we had something like negative 3x plus 4x, okay, we could combine those and we'd get negative or positive 1x. Okay, it's like the same thing here. We have negative 3 radical 7 plus 4 radical 7. We could combine those and get positive 1. I don't know why I'm writing the plus sign on front. You don't need that clearly. 1 radical 7 or just radical 7. So that's the answer for that. Another way to demonstrate this is because there's a square root of 7 in both terms, you can factor that out, and then in parentheses you're left with negative 3 plus 4. So that's the same thing as 1 times radical 7, radical 7. So there's two different ways to think about it. I personally prefer the first way I described because it's kind of like what you've been doing with like terms. So if we had something like negative 3y plus 4x, you can't combine them because they are not like terms. It'd be the same thing if we had negative 3 radical 3 plus 4 radical 7. Notice how they're not like terms, so we can't combine them. So let's go ahead and proceed to the next one. Here we have negative square root of 15 plus 10 square root of 15. You'll notice that we both have a square root of 15 in these, so we can go ahead and combine them. Now, we're just going to keep the square root of 15 attached on at the end. The only thing we're going to be worried about adding or subtracting are the numbers out in front. So we're going to do negative 9 plus 10. Again, it's 1. So our answer is just going to be square root of 15. A lot of these are similar. Let's go ahead and scroll down. Let's do this one. I usually assign the odds, so that's why I'm doing the evens here. So we have negative 3 minus 4. So we have negative 7 square root of 17. And that's exactly how you do that. You just combine the numbers in front, attach the square root at the end. Now let's look at this one. At first glance, it appears that we can't combine them because they're not like terms, but always check to see if you can simplify some of these bigger radicals first. If it's not a prime number or a number with no perfect squares in the radical, then you can't simplify it any further. But if it is bigger and it does have a perfect square within the radical, then you can simplify it further. So if we have square root of 27 here, what I like to do, factor tree. I have many tutorials on how to do this, but essentially factor tree, and we see that we're looking for anywhere we have two of the same number. So 1, 3 is going to escape the radical and 1 is going to stay within. So we're going to rewrite this as, okay, this is the careful part. So a lot of people would write 3 radical 3 and they'd be done, but that is just the square root of 27. You can't forget about this 3 out in front, so don't forget to multiply it by this 3. So then we have, let's write this in blue, negative 2 radical 3. Let me write this in orange just so you see we carried this down. There we go. Plus 3 times 3 radical 3. So first let's simplify that. Negative 2 radical 3 plus 9 radical 3. And you get 7 radical 3. And that's our final answer. So make sure you simplify the radicals first before you add or subtract. Let's do one more just so you get it. Oh, and by the way, let's say you get it to a point where it's most simplified again, and you get something like this. Well, you can't combine them because they are not like radicals, they're not like terms, so you just leave the answer like that. Like that. That's how you would leave the answer. Okay. So here we have 2 radical 6 and plus 3 radical 54. We can't simplify radical 6. There's no perfect squares in it. There's just 2 prime numbers, no pairs. But 54 we can. So it breaks it down into 2 and 27. We can divide by 3. We get 9, 3, and 3. We're going to look for anywhere we have a pair. Here we have a pair. So 1, 3 is going to leave the radical, leave the house. And 3 and 2 are going to stay home. So we can rewrite this as 3. This 3 escapes. Radical 2 times 3. Okay, but you cannot forget about this 3 out in front. That's very critical. So we're going to write 2 radical 6 plus 3 times 3 radical 2 times 3. And I wrote in parentheses this time just so you see that we need to multiply by this, okay, out in front, and that this square root of 54 is simplified as 3 radical 2 times 3. 2 radical 6 plus 3 times radical 6. So we have 2 radical 6 plus 9 radical 6 equals 11 radical 6. All these other problems, there's a final answer. All these other problems are essentially the same. You'll just need to simplify some of these bigger radicals first. Like, let me do number 22 real quick, and then we'll call it quits. So we have negative 3 radical 3 minus, okay, we need to simplify radical 8. At first glance, it doesn't look like it's similar to radical 3. So we break it down to 4, 2, 2. We have a pair of 2's. So 1, 2 is going to leave the house. 1 needs to stay home. This becomes 2 radical 2. So we have minus 2 radical 2. That's what this is. And then we have minus 3 radical 3. Now look here. We only have the radical 3 and the radical 3, but the radical 2 is not the same. So we're only going to combine the red. So we have negative 6 radical 3 minus 2 radical 2. And that's our final answer. Hope this was enlightening, and hope you enjoyed this video. Until next time, be good, be kind, be true, be nice, and be honest, and have a wonderful day.